This video covers tree diagrams and the counting method. As our experiments get more complicated, we need to find ways to systematically find the sample space. One tool we have to write out all of the sample points for an experiment is to use a tree diagram. Consider flipping a coin. When we flip it, one time two results can occur. We can get heads, which I'm going to call H, or tails, which I'll call T. In the diagram below, we call each result a branch of the experiment. What if we flip a coin a second time? This will add two new branches to each of our previous branches. So we have our first branch of heads, and then it can have a second head or tail. Or I have my other branch, tails, which could get a head or a tail. If I was looking, I would consider that there are 4 different possibilities I could get from flipping a coin twice. I could get head-head, head-tail, tail-head, or tail-tail. Again, here's what I just said from the previous thing. Here's my 4 choices, head-head, head-tail, tail-head, tail-tail. Can you see that this will help us solve probability questions? Say I wanted to know the probability of flipping a coin twice and getting at least one head. We can see from the diagram that 3 of the 4 outcomes has at least one head, so our answer would be 3 out of 4, or 75%. Let's look at planning a catered lunch. A company is having a lunch catered for an upcoming conference. Each person is told to select one item from each category from the following menu. For a sandwich, they can have tuna vegetarian or ham and Swiss. For a side, they could have potato chips or pasta salad. And for dessert, they could have cookie or fruit salad. So let's start with how many ways can the lunch be ordered? All right, so we start with pick a sandwich. So that's my first branch. My first branch is the sandwich of tuna, vegetarian, or ham and Swiss. And then they have the 2 choices of a side, chips or salad. And you can see I repeated that for each of them. And then there's also a choice of pick a dessert, which is cookie or fruit. So now when I go down, I can count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So I have 12 choices of how this could be made from people picking their own lunch. How many of the choices have chips or a cookie? All right. So here you can see I circled all the choices that have either chips or a cookie. So you can see here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Sometimes we want to know the number of ways we can do an experiment, but don't need a list of the actual different sample points. For example, we will call parts of the, we will call parts of the experiment tasks. In our last example, we had 3 tasks. We had picking a sandwich, picking a side, and picking a dessert. If an experiment has n tasks, x1, x2, x3, all the way xn, then the number of points in the sample space is x1 times x2 times x3 up to xn. This means I multiply all of the ways to do each task together to find the number of ways to do the experiment. Let's go back to our lunch example. In our previous example of selecting a lunch, there were 3 ways to select a sandwich, 2 ways for a side, and 2 ways to pick a dessert. The number of ways to select a lunch then was 3 times 2 times 2, which is 12. So let's look at ordering a jacket. How many ways could you order a jacket if it's available in 4 sizes, small, medium, large, and extra large, 4 colors, blue, red, orange, or green, and can be ordered as a man's, woman's, or a child size? All right, so we have 3 different things to do. We first need to pick a size, then we need to pick a color, and then we decide if it's a man's, a woman's, or a child. So I have 4 choices for my size, 4 choices for my color, and then 3 choices for man, woman, or child. If I multiply 4 times 4 times 3, it says 48 ways to make a jacket, and notice we didn't have to list any of the ways out at all. So let's take this over to making a password. And this should seem really important because you guys have passwords for everything. I have more passwords than I like to think about, but it really is good for security. So say we had a 4-digit password, and it could be made by using the numbers 1, 2, 3, 4, 5. So how many ways can we do that? Since we can repeat digits in a password, we have 5 choices for each of the 4 digits. This means I have 5 choices for the first, 5 for the second, 5 for the third, 5 for the fourth, which gives me 625 choices. Let's see how many passwords can be made using 2 letters followed by 2 numbers. Assume capitalization doesn't matter. All right. So now we're doing letters and numbers. There are 26 letters in the alphabet and 10 digits. Don't forget when we talk about digits that you're including 0 and 1 through 9, which makes 10. So the number of passwords made by 2 letters and then 4 numbers, sorry, I almost said that wrong. So 2 letters followed by 4 digits. I have 26 times 26 times 10 times 10 times 10 times 10, which is 6,760,000. If you're thinking about passwords, which I want you to think about on this page, do you see where the second case is much better? Do you see how people always saying put a letter in it, put a symbol in it, do capitalization? The more things we add as choices, the more secure we can make a password. Having 625 choices shouldn't make you very comfortable. Having 6 million choices should make you feel like something's more secure. So how about we start with a U-try? How many ways can a couch be ordered if it comes in 3 materials, leather, suede, or cotton, if each material is available in 15 colors? All right, so this is a pretty short one, so I didn't say pause, so let's keep going. So here's my 3 fabric choices, my 15 colors that we can do it in. So 3 times 15 says we have 45 different choices for this couch. Okay. Let's say find the missing information on the license plate. So I want you to look at the picture on the right. If we know that this plate has 3 digits followed by 3 letters, how many plates can be made that start with an 8 and end in an S? So think if you saw an accident and you saw the first and the last, how many people would we have to go through to figure out like what happened, whose car this was? All right, so here I drew in some blanks to say 2 after the 8 and 2 before the S. So the plate, again, repetition's allowed. So I have 10 choices for each of those missing numbers, and I have 26 choices for each of the missing letters. This says I have 67,600 choices for how many plates begin with an 8 and end in an S. So let's do some practical application and just show you where I see this in the real world, because people love to tell me about math in the real world and how it's never used. So this is text on the left from Applebee's Pick 2 menu. And I thought, let's look at how many ways a guest can order an appetizer and 2 entrees from the menu on the left. Okay. When we're doing this, you have 5 choices for the appetizer, so you see I have 5. And then there's no restriction on you and your guest ordering the same thing. So I said we have 8 choices for each person dining after that. So I have 5 times 8 times 8. That says there's 320 ways to order when you go out to eat. Important to note, again, that both of them could have been the same, so it doesn't matter, right? It doesn't matter at all if there's repeated or not. I also want you to note that what's really on this menu, 5 appetizers and 8 entrees, is 13 food choices. So this 13 food choices ends up with 320 pick 2 meals. So you can see how this is definitely something that looks great in advertising. It makes it sound like you have a lot of things going on when you really only have a few choices. So not to like pick on one company and not share with others. I know that Chili's also has a pick 2 menu, and I have a link to it. You can go to the PowerPoint if you want to get to it. But what I thought was interesting, and I added this arrow on my own to it, $20 for 2 menus over 1,000 premium combinations. And I was like, oh, look, they threw a number in there. So let's just see if they're right. So again, if you were to go onto theirs, they have 5 appetizers and 15 entrees. Again, guests select 1 appetizer to share, 2 entrees to eat. So they have 5 times 15 times 15, which comes up to 1,125. I just wanted to note their menu is tricky. In case you go look at it, they get to 15 entrees by offering crispers, which I'm sure you guys know what these are, in 3 different styles. And then quesadilla, they offer as chicken or beef, so they count that as 2. So it really looks like there's way less on their menu, but it comes up to more because of the way they add their sauces. All right, so let's do another U-try. It says a password is formed using 2 letters followed by 2 digits. how many ways can the password be formed? And I'm sorry, I didn't read that. They're lowercase so that you don't have to worry about capitalization. So the first time I want you to not use repetition. So don't use the same letter twice, and then do it again where you can use repetition. And this one I would pause it because this should take you a little bit longer. All right, so let's check out the answer. So the first one, when I take repetition away, the first time I pick a letter, I had 26 choices, but once I used a letter, I can't use it again, so now I have 25 choices. Same thing with the digit. I pick one, but then once I've used it, then I only have 9 choices left. So if I do these 2 letters, 2 digits, no repetition, I have 58,500 different passwords I can make. Part B says, well, put the repetition back in. Then I have 26, 26, I have 10, 10, here's 67,600. So here's 2 more you tries. The first one says, how many ways can a 10-question true or false test be answered? And the second one says, how many ways can an 8-question multiple choice test with 4 choices be answered? Again, pause it. This should take you a little bit, and then come back and see how you did. All right, so here's A. We have 10 questions. Each have 2 possibilities. So I'm kind of picturing 10 blanks. And each of those blanks, I go 2 choices, 2 choices, 2 choices. So I put in my calculator, I did not hit 2 times 2 times 2 10 times. I hit 2 to the 10th. I can write it out for you if you want to see what I put in there. I put in 2 to the power 10. But that's the same thing as multiplying 2 over and over and over again. And I got 1,024. So there's 1,024 different ways to answer this 10-question true-false test. I bumped it up a little on the second one by having 4 choices. So 8 questions sounds like 8 blanks, but each of those blanks has 4 choices. So this time I'm doing 4 to the 8th. So you could do 4 times 4 times 4, right? 8 times, or you could just do 4 to the 8th. And I get 65,536